We humans have brought about dramatic changes in the climate of our planet. Yet only 10% of the world's population is responsible for more than half of global emissions. Climate change is primarily a matter of justice. At the Paris Climate Change Conference in 2015, all countries pledged to limit the increase in average global temperature to well under 2 degrees. But doubts soon began to set in about whether such a target was achievable. Advocates of the science known as geoengineering saw their opportunity. They assert that geoengineering could halt climate change by means of industrial-scale technological solutions. This would involve targeted and massive interventions in the Earth's atmosphere, the oceans, and the biosphere. There are two basic directions that potential manipulation of the climate could take. Solar radiation management involves activities that reflect the sun's rays back into space, so the climate heats up less. Carbon dioxide removal involves activities whereby the greenhouse gas carbon dioxide is sequestered from the atmosphere. The most widely discussed application of this kind on land is BECCS, which stands for Bioenergy with Carbon Capture and Storage. What is the underlying concept of BECCS? It is about the combination of two controversial technologies, bioenergy and CCS. Large areas of land would be turned into plantations for fast-growing monocultures, trees or crops selected for their ability to extract CO2 from the atmosphere. To meet the targets set in Paris, however, huge areas of land would have to be set aside. Indeed, the surface area required has been calculated to be that of India at the lower end and twice the amount of land currently used for global agriculture at the upper end. After felling or harvesting, the monoculture trees or plants would be burned in power stations to generate electricity. The carbon dioxide released by combustion would first be captured and liquefied before being pumped into depleted oil and gas reservoirs or underground aquifers for final storage. In theory, at least, this method would filter one of the greenhouse gases out of the atmosphere on a gigaton scale. So what are the arguments against? The huge surface area required would drive up land prices and adversely affect food production. The result would be a sharp increase in food prices, and small farmers would lose both their land and source of income. The transformation of previously uncultivated land and prairies into monoculture plantations would destroy natural ecosystems and reduce biodiversity. BECCS could double global consumption of water and fertilizer, which would lead to additional emissions and water scarcity in many parts of the world. In order to create large tree plantations and fields, the soil must be plowed and tilled, which releases carbon dioxide. Tractors, harvesters, and transport generate additional emissions. The result would be a new resource and energy-intensive mega-industry. Furthermore, no one can know for certain at this stage whether and for how long liquefied carbon dioxide could be safely and reliably stored underground. It is therefore highly questionable whether BECCS would really remove CO2 from the atmosphere, and even if it did, then only with devastating consequences for human communities and for ecosystems, with great uncertainty as to the long-term effect. What is it that makes geoengineering technologies such as BECCS so attractive despite the drawbacks? It is because they offer the world the tantalizing prospect of a supposedly technological solution to climate change, which relieves them of the obligation to make drastic changes to their climate-damaging methods of production and patterns of consumption. Geoengineering schemes such as BECCS are a dead end that distracts us from the real solutions. What we actually need is a much more systematic reduction in emissions, as well as strategies that radically transform our economies. A rapid exit from fossil fuels, coal, oil, natural gas. Decentralized energy production from solar and wind. A worldwide reduction in the consumption of raw materials and energy. A transition from industrialized and fertilizer-intensive agriculture to agroecological food production. And there are other factors to consider. Our global ecosystems, rainforests, moorland and oceans, store large amounts of CO2. They need to be protected and conserved. In addition, damaged and degraded ecosystems must be extensively but carefully restored. We can do this by reinforcing the rights of those who have been using and safeguarding these ecosystems for millennia, local and indigenous communities, for whom our forests are not just a livelihood, but also their home. Above all, climate protection is a matter of justice.